Okay, so we're going to go over Multicore in TempleOS. First, let's show what we have. This is, what do we have? 6 cores. 1, 2, 3. What do we have? 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4, 5. 6 cores. I did 6 because I wanted a spare for, I'm running in VMware, so I didn't want to take all of them away from the host. Anyway, so what we do is we divide into 6 tasks, and then we assign strips of land, and they go until they time out. So we get a little bit of a flicker. I'm also I'm running a frame grabber, which is grabbing 8 frames a second. So what's on the monitor is 30 frames a second. What's on the what you're seeing is 8 frames a second. Anyway, so yeah, I decided this is acceptable. I used to lust for more and more acceleration to do more and more, but this is acceptable. So I'm not disappointed with this. We're not going to hardware accelerate this. This is you might think I'm nuts, but if an amateur can make a game like this, that's good enough. Mission accomplished. He can, if he's ambitious, he can. I think he'll be tired by the time he does this. But if you were ambitious, you could make a nice story. I made fishing, going for fish. There we can go dive for fish, then come out of the water. So if you wanted to make a nice story about flying as an eagle, you could do a nice story flying as an eagle. Anyway, so I made a first-person shooter. The interesting thing about that is the code has graphics in it, so you can see my first-person shooter. It's not fun. It's not fun making graphics, to be quite honest. Maybe we can get some better tools, but it's you'll probably lose enthusiasm, although you get better at it. Once you get better, it's still. Anyway, so this is 1 core. This is 1 core. We're using, when the screen changes, it uses more CPU. So we're hitting a lot of CPU. This is 1 core. So here's what I want to talk about. I want to talk about an example. This is just what we're going to do is I'll do a should I do one where we start and stop? Okay, one of the first things you learn is be consistent and copy. MP, is there not? Okay, I give up. Okay, so okay, MP. Oh, this is not going to work. Well, anyway. So we go control. Oops. Oh, I'm lazy. MP not done flag. Control. FD MP not done. Okay, so what we do is we come in here, grab that, go over here. Now I was trying to save some time. This is, I'm borrowing my own code. Okay, good enough. Okay, so so I think you're supposed to have a multi-core flag in a its own cache line that's like 64 byte aligned. To be honest, I don't have more than one flag, so I get away with not doing that. Anyway, my job. How about that? I64I. This is my job task. Okay, this is going to be while not done, yield. Okay, what we're going to do is see how many swaps a second we can get. Okay, so this is we can call this MP demo. So we set so we initialize spawn. My job task. Let's doesn't. That's the parameter. There's one parameter. Spawn. Oops. Spawn takes. How are we doing on time? 8 minutes. Okay. Task address, task data, task name, target CPU. So we call this my job. And okay, here. Okay, so there's the worker is going to sit done equals false. Done. Okay, I don't usually use that short, but how about MP done? That's more like what I would do. Okay, so we have a Boolean that when we're all done, we set that. And then we have individual flag bits. There's 8 cores. We're good up to 64 cores. GSNum is the core number. We could pass it in as a parameter, but we don't need to. Normally you do something important. So what we do is we wait in a loop and we swap in the next task. So we yield the CPU to the next task, which usually is back to us again. So this swaps itself out and then swaps in another one. And when we get the flag saying we're all done, then we acknowledge. I think we want to say not done. What we really mean is not done. That's getting hard to understand. The flag is a 1 to begin with. Let's say you have 8 cores. This is going to be 8, 1 to the 8th. 1 shifted over 8 is 256 minus 1, 255. So if we have 8 cores, it's 255. And then when we, each one that finishes clears a bit. So not done becomes false. If you're not familiar with logic, you might not understand. Anyway, so so we're going to spawn a task on all 8 cores. This tells us how many, or 6 cores. We have 6 cores. We're going to press a key, and then we're going to issue. We're going to tell it that we're done, and then as long as there's still one running, we yield. That's so that we don't finish. If we finish before they finish, then guess what happens? The code memory for the core gets reused, and it crashes. So you have to wait for it to finish before you exit. Otherwise, the code memory for this function gets reused and it crashes because there's still somebody in it. It's like, well, anyway, here we go. Let's test it. F5, ready? Bam, look at all those cores going 90, 90, 99. Now we hit a key, done, and they're all back to 0. Okay, it worked. Let's see if it runs twice. Yeah, good, good, good. Okay, so here's what I wanted to show off. Okay, so we can get rid of that. So here's what I wanted to show off. On the wallpaper, there's the number of swaps per second. Watch this. Okay, so we just caused some new tasks to get created. And look at this, we're doing 4 million swaps a second per core. Plus we're doing a frame grabber. Okay, that's what I wanted to show. 4 million tasks a second on all cores. Whoa!